All right. Today we're going to look at transformations. We're going to start a unit on transformations. There are a lot of different types of transformations. The first vocabulary word that we have is isometry. And isometry is a transformation that preserves congruence. Okay? So it retains its shape and size. It just moves to a different location. Okay, so the only, no, I don't think we did any transformations already, have we? Okay, I don't think we did. Let's just look at what we're doing today. So today we're doing translations. When you were in middle school, you did translations and your teacher called them slides. They're just where whatever you have moves horizontally and vertically. Okay? All right. So the most important part of what we're going to be looking at is what's called coordinate notation. And if I ask you to describe the transformation or the translation in coordinate notation, it has to be written in this format. Okay? So this is the original point, and this is how the point was moved. So if you look at your example right here, it says for this translation, we're going to take every point and we're going to move it right 3 and we're going to move it down 4. So remember when we say right 3, that is the X in this direction. When we say down 4, that is in the Y direction this way, okay? So when you write the notation, you're using that same reference of X and Y. So right 3 goes in the X positive 3 direction. And when it says Y minus 4, it says I'm going to go in the Y direction negative 4. That's where each of those notations come from. Okay? All right. So let's take a look. We're going to take the words and we're going to write them in coordinate notation. Okay? So when it says right 3, right is an X direction to the positive. Okay? Because here's my coordinate. X, positive's to the right, negative is to the left. The y-axis, positive is up, negative is down. So right 3 is in the X direction positive, up 2 is in the Y direction positive. So when I write my coordinate notation, I'm going to say X, Y, every single point is going to move X plus 3, Y plus 2. That's the complete coordinate notation. Okay, so let's look at the next one. So we're going to begin coordinate notation. Okay, left. That's an X in the negative direction. So X minus 3. Down. That's a Y negative direction. Y minus 2. Good? All right. Number 3, every point moves one unit down, no, right 1 unit, down 5 units. So we've got XY moves right 1 unit. Right is an X positive direction. Down 5, down is a Y negative direction. All right, number 4 and 5 have something just a little different, so pay close attention to how I'm going to write it. So we've got XY moves. Left is in the X direction. So X direction, left is negative. So X minus 6. Does it say anything about the Y? No. Does the Y just disappear? No. I still have to account for the Y, so I just put Y. it does no change, so it just stays whatever it was, it's still the same. Okay, so look here, it's going to be similar, they're just going to be traded. So we've got xy becomes up 7. So up is the y positive direction. So put it where the y belongs, y plus 7. Nothing happens to the x, so it's still just x. That is coordinate notation. You need to be able to write coordinate notation, and you need to be able to graph by reading coordinate notation. Okay? All right. Let's take a look at we're just doing translations and reflections today. So reflections, okay? So a reflection is a mirror image of a figure across a line of reflection. Each point of a reflected image is the same distance from the line of reflection as the corresponding point of the original figure. Okay. So before we look at the rule, I just want to talk about what it means to be a reflection, how you can draw it by just looking at the graph. So I'm going to reflect this polygon, HJKL, across the x-axis. This is important.
Your number, that's why I put it with
You have to know what you're reflecting across.
That's not the huge deal. The huge deal is to remember
so that I don't lose
the x
track
goes with
of
the
what I'm
6.
supposed to be doing.
In the
I'm
y
gonna
direction,
highlight
the square root of 9 is 3.
x-axis.
So in the y
That's what I'm
direction,
going to reflect across.
I go 3.
Okay. So
Go ahead and graph
if
that.
K
1, 2.
is 1 unit
X
above
direction 6.
the
Coming from over
reflection
here.
line. K
1, 2,
prime
3,
is
4,
1,
5, 6.
1 unit
1, 2,
below.
3, 4, 5, 6.
If J
Y direction, I
is
travel
3
3.
units
1, 2, 3.
above, J
1, 2, 3.
prime is 3
Ellipse.
units below.
Okay.
L is 1 above.
And again, the
L
major
prime
axis,
is
that's
1
like
below.
the bigger diameter. That
H
would be like
is
this.
1, 2, 3, 4, 5
So
above.
6
H
plus
prime
6 is 12.
is 5 below.
Minor axis, that'd be like the minor diameter. 3 plus 3 is 6. This
All right, so
stretches
this
further in the horizontal direction.
my image,
That
my
makes it a
reflection
horizontal
across the
ellipse.
x-axis. Okay? But there is a rule,
It's
and
pretty
these
cool.
rules can be really
All right.
helpful.
Number 4.
This rule
Center,
says
opposite,
whatever the
comes
original
out of the
point
parentheses.
is,
So negative
the
3,
reflected point
negative 2.
has the same A.
This is
and
the bigger one, so it's going to be
opposite
A.
B.
So I'm going to start here.
Okay?
The
Doesn't
x
mean this
direction,
will always be
square
negative.
root of
It
9
means
is
it
3.
will always be the opposite
That
sign.
leaves in the y direction, the
original.
square root of 4 is 2.
So let's look at how we would have done this.
Going to go ahead and
using the
graph.
rule.
Center, negative
So if
3,
I'm going to go
negative
ahead
2.
and take H, I'm going to
In
say
the
H
x direction, the
is
radius is 3.
1, 2, 3, 4, negative 4,
1, 2, 3.
5.
In the y direction, the radius is 2. 1, 2.
So based on
1,
the
2.
rule,
That's my
A
ellipse.
prime, look at what the rule says. The
It's
A
a little
is the
hard
same.
to tell, but I can look here because the 3,
B
the
is
bigger
the
radius
opposite
is under
sign.
the
So
x.
instead of a positive
that means
5,
it opens in the
it's a
x
negative
direction,
5.
horizontal.
And if we check our graph, that's exactly
Major
where we
axis,
put it.
that'd be like the biggest diameter. 3
let's
plus
do,
3 is 6.
Another
Minor
example.
axis, like
Okay.
the smaller diameter. 2 plus
K.
2 is 4.
K is at 1, 2, 3,
One more.
1.
Center,
So
opposite
based on the
sign.
rule,
4, negative
A
1.
prime,
4.
the A stays
Negative
the
1.
same.
This one is
And the
bigger,
B
so I'm going to
changes
start with
sign.
it. In the y direction,
All right. So
The
that's
square
the
root
rule
of 16
for
is
reflecting
4.
across the
the other
x-axis.
piece
Across
in
the
the x direction, the square root of 9 is
axis.
3.
The x stayed the same.
So to graph
the y
it, we've got
changed
2,
signs.
3, 4, negative 1.
Here's our rule for
In
reflecting
the y
across
direction,
the
4. 1,
y
2, 3,
axis.
4 up.
The
1,
y
2, 3,
stays
4
the
down.
same.
X
and the
direction,
x
3.
changes
1, 2,
sign.
3 to the right.
So let's
1,
go
2,
ahead and
3
list
to the left.
A, B,
Connect
and
the
C.
dots.
And we're going to go ahead and reflect this across
Okay.
the y-axis.
The major axis,
using
that's
the
like
rule
the biggest
instead of counting.
diameter, that would be 4 plus 4 is 8.
So A
Minor
is
axis,
1, 2,
the
3,
smaller
4.
diameter, 3 plus 3
1, 2, 3, 4.
is 6.
B
This opens
is
bigger
4,
in the
negative
y
1.
direction. That makes it
And
a
C is
vertical
1, negative 2.
ellipse.
So if we're given the equation,
rule
we can
says
find the center
first value
exactly
changes
the way
sign.
we found it for a
So
circle.
let's go ahead and mark A prime,
And
B prime,
underneath,
C prime.
these are the two different
The
radiuses
first changes sign.
squared.
The second one stays the same.
So this
The
radius
first
squared
changes
is 9,
sign,
that makes the radius
second one
3.
stays the same.
This
The first
radius
changes
squared is
sign,
16,
the second
that
one
makes
stays
the
the
radius
same.
4.
Now
How
can
do I
graph
know
the
which direction that
reflection
radius
using my
goes?
points.
I look
-4,
at the 3,
4.
the radius
That's
of
A
3
prime. Make sure
is
you
under the
label
x, it goes in the
your
x
points
direction.
and your primes.
The radius of 4 is under
B
the
prime
y,
is negative
goes
4,
in the
negative
y
1.
direction. Right, now we can take that and reverse it. We
And
can
C
take a
prime
graph
is negative 1
and write the
to negative
equation.
2.
So first we're going to fill in the direction and the center. The direction is horizontal because it stretches wide. The center is
back
2,
up to this
3.
original word, isometry. Okay?
Okay?
Both of
So the
these
top of the
transformations
equation
are
is just
isometry.
like the circle.
That
I'm going to
means
have
when
parentheses
you
squared plus
do the
parentheses squared.
transformation, it
These
has
go
to still be
inside
the same
as the
shape
opposite
and same
sign. So
size.
x minus
If
2.
something happened,
Y
and when you're done,
minus
it's
3.
not the same shape, or it's
For an
not the same
ellipse,
size.
it
You've made
always
a mistake,
equals
and
1.
You need to go back.
Under
and check.
here, I put the radius in the x
So
direction
when we
squared.
look at
Under here,
say,
I put
our
the radius in the
reflection
y
examples,
direction
these
squared.
are still the same
So
shape.
first, I'm
the
going to go
same
ahead and
size.
list those. So
They
A
just have a
and
different
B. A is
orientation.
the biggest, so we're going to go here. A.
Same
1,
shape,
2, 3,
same
4,
size.
5.
C is
A
1
is
to the
5,
right,
and
so
it's in
C
the x
prime
direction.
is 1 to the
That
left.
makes A squared.
B
25
is 4
in
to
the
the
x
right,
direction.
so
Let's
B
not put
prime
that. Let's
is
leave it up here because we're
4
going to
to the
count
left.
5. Yeah,
Okay.
let's put it in the x direction.
So those
Okay.
are the rules for
The smaller one,
reflecting
B,
across the
I'm gonna count
x-axis
2
and the y-axis.
In the y direction.
Okay, you
So
can
that's
use the
going to be a
rule,
4,
or you can count.
2 squared.
I think
in
for
the
both
y.
of these, either one
Under the x
is
goes to
useful.
25.
Okay. There
Under
are
the y
some
goes a 4.
situations where I'm going to have you reflect
So my
across
center here is
other
positive
lines,
2, positive
and the
3.
rules won't apply to these. You have to
The
just
radius
count.
in the x direction is
Just
the square
use
root of
your-
25,
your
which is
skills,
5.
right?
The radius in the
Biggest
y
part I
direction,
see
square root of
students
4,
having trouble
which
with
is 2.
is graphing the line
Okay,
that they're
do
going
one
to
more.
reflect across.
Last
If
one.
you don't
Center
graph the
is
line, you
1,
cannot
2, 3,
reflect
4.
across it.
Negative 4, negative 2.
So when I look at these instructions, I'm going to graph.
Direction
Actually,
is
I should probably
vertical.
say I'm going to reflect triangle
We're gonna do
ABC
A and B.
across the line.
A is the
X
big